Now this video is on the anti-sway bar on this 78 Chevy Blazer four-wheel drive and exactly how it works. After being an R&D and design engineer and reading papers and seeing information online about this, there's some gross information out there about what this bar does. And this gets into fairly complicated mechanics. The simple explanation is that there are two kinds of front axle. This is called a dependent axle because what happens on one wheel is transferred through a solid axle more or less over to the other wheel. An independent suspension would be a rear-wheel drive car with coil springs and control arms on each side. And those assemblies are connected to the frame, but they're otherwise independently able to go up and down. This is becoming a little heavier four-wheel drive vehicle. It's only a half-ton truck, but it has a pretty heavy running gear. And with a solid axle, when both wheels hit the same bump, like a going over a speed bump, then as you can see just under the bumper there, the leaf springs both compress, deflect upwards by the same amount because the speed bump's the same height on both sides. The chassis, because of its 2,000 pounds and its inertia, tends to stay in the same place. That's Newton's laws of physics and such. So those wheels go up the same amount. The spring compresses. The shock absorber works with the spring to prevent oscillation. So there are three forces involved here. There's a vertical force or normal force from the bump pushing up on, let's say, this front driver's side wheel. There's a reaction force of the vehicle pushing down against that because of the chassis mass. The fact that it's a more or less solid axle means that when this wheel goes up and the other one doesn't, then that wheel tends to stay on the other side in contact with the road, and this wheel tries to leave the road, and that means that the axle tilts. That's a rotation. That's a theta. So that's a force upwards. That's a rotational force that results into both an upward force and a lateral force sideways. Two force components, F of X, F of Y. Then there's oscillation. The oscillation is the dangerous one. That's what this truck was doing before I tore the steering box out and found the bad loose bushings on the sway bar. This truck was literally dangerous to drive. It would try to take you off the road on the right-hand side. So we had to be prepared and jerk back on the wheel and shake side to side down the road to try to keep it in the road. Literally dangerous. Now, the myth out there is that the stabilizer bar, the control bar, and you can see it's lighter colored under there. There you can see it better because I've taken it out, put new I bushings, EYE, in the back, and the new chassis bushings in the front, and cleaned and painted it. It's a U-shaped bar. It's more or less straight across in the front. The arms go more or less straight back, except in this vehicle, the bar on the passenger side is not straight. So the information online is that bar is to stabilize the body, and that's false. If we zoom out, the body on this truck is what, 500 pounds, maybe? The chassis rails are, I don't know, 100 pounds each. They're stamped C-section steel, I don't know. The body and the chassis rails may be 600-700 pounds at the most, maybe. It doesn't matter what the body does. Okay, some people take the body off and go four-wheeling. You get a ragtop Jeep with plastic doors, take the doors off when it's really hot, you got no body to it. So what's the point? Well, the body is not what's being controlled here. What's being controlled in the context of hitting a bump on the driver's side only, the axle rotating through a theta and imparting a sideways force, is that the body and the chassis rails are trivial mass. Because they're relatively light, you cut off a piece of that frame section a foot long, you could pick it up with one finger. It weighs nothing. The body and the chassis are distributed mass, including the back. What's really happening here is that this sway bar and front suspension is here to control the mass of the engine. The engine by itself weighs as much as the body, and it's a central mass whose centroid is up high. The higher that mass goes, the more tippy the vehicle is going to be. That's why race cars have the engines way down low without oil pans. You want to get the center mass of that engine down, you put it in the back. That's where we get mid-engine from, and take the oil pan off and put a dry sump on it and have an external oil reservoir. That allows dropping the CM of the engine several inches and makes the vehicle more stable. So the body means nothing except that the seats are fastened to it and the driver is in the seat and holding the steering wheel. Now, when this bump is hit on the driver's side, that translates into a side-to-side force. F sub y, the vertical force is compressing the leaf spring. That's working against a shock absorber. The F of x, the side force, cannot be resisted by the springs. The springs are tall and tippy side to side. The springs are very stable front to rear because they're 4 feet long. What the springs do is control the front end from bouncing up and down. Hit a bump, hit a speed bump, the front end goes boing, 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 boing. Without the shocks, it oscillates. With the shocks in place, the front end goes bump, and that's it. So these springs absorb the deflection, the shocks and the springs dissipate the energy. If the energy isn't dissipated, it results in oscillation. Oscillations are dangerous. The spring is on its own eye mounts, EYE, a steel tube inside, a rubber bushing, a steel casing on the outside, and a through bolt right there. That's free to rotate up and down. Otherwise, the springs will bind. When the front right or front left wheel only hits a bump, it tries to throw the chassis sideways. And that's the purpose of this bar. I read several so-called engineering, scientifically published papers that are all saying the same thing. It might apply to some vehicles. It doesn't apply to this one. And what these papers say is that each of these spans in this bar are a torsion element, and they show circular arrows around each part of that bar twisting. So in theory, if the driver's side wheel only goes up, then this length of bar twists. And I can assure you, in this vehicle, that bar is not going to twist. That bar is on the order of the thickness and the kind of material that Chrysler used in the torsion bar suspension. And that is not going to give twist in there. That bar is extremely rigid. It's hardened steel. It's 1.25 inch diameter. So what that does, since that bar is not going to allow much twist, there might be some torsion. There might be some torsional twist in this stretch here. But see these bushings, the blue rubber and the black rubber in the eye bushings in the back are way too weak to resist those kind of forces. So the purpose of this anti-sway bar is to bolt onto the axle over here near that wheel and over there on that wheel to keep the body from being thrown sideways. And the reason for that is not the body, it's the chassis. And the reason for that is because of the steering gear. The steering gear is bolted fast to the left side chassis rail. So when the chassis moves sideways, so does the steering box and so does the pitman arm. But the destination for the steering is the wheel, and the wheel is part of the axle, and the wheel doesn't go sideways. So when the body is suddenly forced sideways, that makes a steering output change. That can literally steer the wheels, that sideways bump. Now, motion relative from the chassis rail to which a steering box is fastened and the body can throw the driver's side to side and cause steering input changes, which can also be hazardous. So in four-wheel drive service, we know sometimes we keep a tight grip on the wheel to hang on, to keep our bodies from throwing around, or sometimes we kind of let loose a bit so that the movement of our body doesn't cause steering changes. So that's what this bar is for. This bar operates in two ways. It resists that side thrust by being a rigid member. It basically locks the axle to the cross member here to the frame. But when both wheels go up and down the same, there's no side load. The trailing, if you will, the trailing portions of that bar from here back to there are mounted to exactly the same point as the front half of the leaf spring. There, the leaf spring is bolted fast to the axle. Here it's bolted with a rotating member to the front of the frame arm, or the frame rail. So the problem with installing this bar is that it was not correctly designed. The installation was not correct originally. And back here we see the eye bushing with the bolt removed. And that goes into that blue mount. You can see the U-bolt from the axle going up through that mounting plate. The bolt through that eye bushing goes into that plate on top and fastens down. The problem was the bolt is too short, and it allows that tube inside the eye bushing to be clamped fast against that mount and doesn't let that rotate. That point there, those eye bushings are in steel tubes for a reason, so that they're free to rotate when the suspension goes up and down in the front. Otherwise, it's trying to resist the motion of the spring. So they should have made the bolt a bit longer and maybe made the bolt a machined length. So there's a little bit of freedom for that arm to sway up and down a bit as the front of the vehicle goes up and down. Here's the eye bolt EYE with hardened 0.125 steel washer. And this smooth shoulder is where there's part of the old eye bushing. And you'll see that later on this video, how and where to install that. But that goes like that through there and bears against the washer. The steel tube inside the bushing is smooth, and it rides on that smooth shoulder. That's supposed to be able to rotate. If this bolt is too short and it tightens down this head against that and against the spring mount, this can't rotate. So that will tend to destroy the rubber. And that's what happened in this vehicle. So the fix for that is that I've gone to the hardware and I've bought a couple of steel bushings. Stupid expensive, but they work. And have taken a piece of fuel line, piece of 3H fuel line with a pencil inside of it, put that bushing over the pencil, and then put that fuel line pencil and bushing inside the hole where that bolt was removed from, all the way back until it stops. And then as it stops, that pencil is pushed back in, and then shake it loose, and then the bushing is left inside the hole. Then follow it with the bolt, and that will space the bolt out enough to give just a little bit of freedom for this bushing to rotate. We don't want a lot of side-to-side play because the purpose of the bar is to resist that. But we also don't want this clamped down so tightly that it can't rotate when the front end goes up and down evenly, because again, that interferes with operation of the springs. Like any other threads, make sure these threads are clean. You can see here where there's some rust, where that wasn't quite engaged with the threads in the mounting block, or some moisture got in. But when installing this, since there's no lock washer in this system, put some medium strength Loctite on about 3 of these threads to lock that bolt in. I'm going to torque it down to about 20 pound-foot. And then put some synthetic brake and caliper grease, very, 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 very thick, on this smooth shack. Then install the bolt once the spacer has been put up inside there, and the bolt will contact on that and tighten against that. And the way to tell there's just a little bit of clearance is that afterwards, when the bolt's tightened, the washer should rotate. It shouldn't do much of this, but it should be free to rotate, and that guarantees this bushing, the steel sleeve in that bushing, will be free to rotate just a touch. There are engineering papers online that say that this stabilizer bar is a torsion element, and all 3 members rotate all three are torque members, and that's wrong. That's wrong on this one because this arm over here is a different shape. It goes over to here to that blue bushing. It goes back, then it bends over, and then back to reach that mounting point. That makes the stance of it wider. There's going to be no torsion in that bar. It's too stiff over here. So maybe in other vehicles, these members are intended to be torquing elements. Not in this vehicle. That bar is extremely Mongo heavy and hardened steel just to keep the chassis from swaying. So just to control side to side. Now here's the original installation of the bolt with the washer. That's not correct, because tighten that down, it'll tighten that steel sleeve in there and try to rip the rubber out of it. So I yet have to take that bolt out and put the spacer back in there. And this is the other side which has a new eye bushing put in. And the video after this will show the problems with the fact that apparently nobody has a correct eye bushing. I had to modify these. As to these two front bushings, they're generally the same kind of design. There's no reason to have those steel clamps tightened down enough to crush that material. This vehicle here, I had to put in shims. You can see the plastic, two pieces of PVC plastic with holes for the bolts here, because this vehicle was in an accident many years ago and it's twisted the frame. And so when the eye bolts are put in here, and this rod was rotated up in contact with this front frame, this bracket here landed on the frame. This one had a gap, and years ago I saw that and I assumed it was because the eye bushings were in a bind, and I just tightened these down. Well, that was the wrong thing to do because it destroyed the bushing. So because this side of the frame is up a ½ inch higher than the other side, leaves a gap in there. So I made a ½ inch thick PVC spacers to put into there. Tighten these down. This shouldn't tighten enough to compress and distort this material, because if it does, let's roll around on the floor here. When that does, here's what happens. It destroys the bushing. So another little modification. This vehicle was in an accident that was necessary. If you've done a lot of four-wheeling and maybe the frame's a little bent, may have to do it. But I would make sure to guarantee that these two things are shimmed into position within, I'd like to see them within 60 thousandths of being the same level. It's not difficult to get some hard plastic material to make shims with. There are not tremendous forces here, else this couldn't be natural rubber. So, critical point, I'd recommend natural Buna rubber. These are shock absorbers. These eye bushings and these front bushings are made of rubber to absorb vibration, which is set up when the vehicle tries to oscillate side to side. Put too hard a material under there under the false excuse of better control, and it'll cause damping. The front end might tend to oscillate. So I put somewhat harder bushings in the front, good Moog parts, because pretty much all that's going to do is absorb some vibration and a little bit of rotation. But notice that when the front end goes up and down evenly, the center of rotation is here on the line through the centers of those bushings. And the arm back there is what deflects up and down. So it basically does this, rotates around that point. So if this is the center of rotation and there's about 15 degrees rotation back there, because I saw about a 15-degree wide mark on one of the washers, then there's a trivial amount of rotation here. Just assume this bar is more or less still. So there doesn't really need to be a clearance up here, but it also shouldn't be tight enough to crush the material. 78 K5 Blazer 4x4. Just redone the steering box. Nice pretty paint. See the paint? That's paint. Took off the stabilizer bar. Bushings were no good. This one here is called the eye bushing, EYE, because it fits through that hole in that arm. And the reason the ones that go on the front are split is because they won't go over that bulge for that eye. but that bore is about 1.3 to 1.32 inches, and the only bushings that appear to be available are these 6655, and they are wrong. Wrong part. They're the right general design, but their OD on the rubber is 1.52, give or take, and that just happens to be the size of the bushing for the leaf springs, not for the eye. So I couldn't find anybody that has anything. I looked online. All the numbers have this 6655, so they're going to be the same thing. So the fix for that is a 5/8 bolt, a couple of nuts, and tighten that puppy down. I put some cardboard down inside the sleeve. The sleeve is 3/4 ID by about 0.96. And I chucked that up in a drill press here. I've modified this drill press to be a more or less commercial grade with the variable speed drive. You talk about slick. Let me turn Pat down here. Jamming to some Pat Benatar. But I've reduced the OD of that to about 1.375, and it's rather soft and compressive, so I'll see if that'll press in. But the tool to do that with is a great big wood rasp. That's for coarse removal of wood. Finer than the axe, not as fine as sandpaper, and also used 60 grit industrial sanding discs and some of this about 200 grit industrial sand cloth to do a little finishing. It's got about the feel of a used drag race tire. So that gets the OD down to where it ought to fit inside this. If it doesn't fit, we must have quit. I'll grease it with a little bit of silicone lube on the outside to press it in. The other problem is that this assembly is not correct. These are the bolts that go through the eye bushing into the mounts on top of the leaf springs, and has a washer on each side, one under the head, one at the other end. And the problem is that bolt is too short by about 0.3 of an inch. The washers are about 0.1. So it bears down and it clamps this bushing, so that pin, because the smooth shank of the bolt is a pin that should be able to rotate a bit inside that bushing. When it's clamped down, it can't rotate. And this arm, we're looking at it from above and from the back. When there's cornering and braking, the front end goes down. That bar can't resist those forces. That's a torsion bar. The papers I've read said that there are 3 torsion elements here, one in each straight span. And notice the driver's side over there is not straight. That's interesting. And that must be for a reason. But I don't know what it is. But that bar offers no torsional resistance from the front end submarining, as we call it. Step on the brakes, front end goes down because the weight transfers forward. So this bar between the eye here and this mounting point for the bushing that goes on the front subframe, where did it go? Right here. If you'll notice, that front subframe here and the mount on top of the spring are exactly the same points as a leaf spring. So if those fits with those bolts are clamped down tight, that tries to oppose the leaf spring action. And I found information somewhere online about, is it Nolene or whatever it is, that actually allows these to free float. Now you don't want them to be able to go side to side, but it needs to be able to rotate just a bit. So what I'm going to do is I'm going to put shims down inside the hole. I may glue them on the end of this bolt. So there's just a touch of clearance, and I don't see these washers do a thing. So the washers will take out about 0.2, and they don't really do anything. So don't want the bushing to go side to side, but it should be able to rotate a little bit. And as evidence of that, where did it go? One of these washers had wear on it through an arc that looked to be about 15 degrees. I don't know where it went. I've scraped the junk off of them, but right there. See, there's now at the bottom, there's a wear arc that's about 15 degrees. So the thing's trying to rotate. So not good to have that in a bind. So there's the answer. Apparently the correct eye bushings aren't available. Like other stuff on old vehicles, oftentimes you end up having to make it. But that's the precision. Precision make good parts or sources in case 6655. So, and here are the front bushings. The front bushings are missing an important thing here, and that is the top of these are smooth, but the correct ones have this ridge, so it can't be pushed side to side because this assembly is being loaded side to side. So up inside the original factory bracket, there's that relief that should have this up in it. So since we're not going to be ever four-wheeling this vehicle again, I don't really care. If one of them tries to jump out, maybe I'll put a different bushing on it. But so far, not a big deal. So there's the story on the eye bolt bushings. And mainly because I just happen to have some, give the eyes the light, dressing out with these ball hones, which, by the way, that's awfully fast. It's supposed to be run at low speed. Those are abrasive grit ball hones. Just smooth the inside a bit, so maybe the bushings will press in a little easier. And with just a little touch of brake fluid on the rubber, because rubber is generally resistant to brake fluid, right? But rubber doesn't like petroleum. So maybe some synthetic brake fluid, but it's pressing right in with this C-clamp, a 6-inch. Of course, I'll need a receiver, a socket over here when the other end pops through, but this is getting it started. It's going in by turning that shaft by hand, so easy press.